For the part 2 of our deploy Azure resources using Terraform, so I have deployed a resource group, a single resource group without any resources inside it. Okay, so we see a blank resources. So if we look at our Visual Studio code, this was our Terraform code. So we have our single TF file or Terraform file main.tf. So we have the providers block. Okay, so Terraform, and as well as the resource block, wherein we have the resource Azure RM resource group with the name RG, and to deploy with the name RG-Terraform, and location will be Southeast Asia. Okay, so we have done the Terraform commands like Terraform init. So we have the providers here. Okay, so we have the Azure RM, and we have this one is Azure RM. We have the lock file as well as the Terraform state. Okay, so for this video we will try to improve on the previous part 2 deployment, wherein we have only a single Terraform file and we have a single resource only. For the new video, or for this video, we will make use of new Terraform file, and we will deploy more resources or more basic Azure resources. So for this video, we will deploy Azure resources following this diagram. So we have the Azure subscription, which is a logical container used to provision and manage Azure resources. It is closely tied to billing and acts as a boundary for resource management and deployment. Next, we have the resource group. So in this diagram, RG-Terraform, but for this video, perhaps you will try to add, like for example, RG-Terraform part 3. So a resource group is a container that holds related Azure resources. Next will be the virtual network in this example, in this diagram. So vnet-example. So an Azure virtual network is a service that provides the fundamental building block of your private network here in Azure. Okay, the VNet, although not illustrated here, typically carries the bigger CIDR block. For instance, 10.0.0.0/16. Next will be the subnet for which our virtual machine will reside. So a subnet enables you to segment the virtual network into one or more subnetworks and allocate a portion of that virtual network address space into that subnet. For instance, in our example is 10.0.0.0/16. The subnet could be 10.0.0.0/24, or the subnet could be whatever you like. For example, 10.0.10.0/24 or /25, and wherein your VM will make use of that subnet. Next resource is a prerequisite before we can create a virtual machine. And in this scenario, in this illustration, we have an example NIC, or it's a network interface. A network interface enables an Azure virtual machine to communicate to the internet or to Azure services like your storage accounts or Blob, or even on-premises resources if this network is connected, having a virtual private network going back to your on-premises. Then you'll have your disk. So it resembles the hard disk of your physical computer or even a laptop. So a virtual machine will require a disk. So typically you'll have the OS disk and a data disk. To make this illustration simple, we have the OS disk. Then lastly, we have the virtual machine, so commonly shortened to just VM. So it has CPU, memory, disk to store your files and connect to internet or your other resources if needed. Now let's go back to our Visual Studio Code. So unlike in part 2 wherein we only have one main.tf file, so in our part 3 for this demonstration, we separate it to 4 Terraform files. So namely the main, the output, the providers, and the variables.tf. Let's check first what's inside the providers TF file. So perhaps to recall what's inside the main, so we have the Terraform block and the provider, the Azure RM provider block, and we have the resource here. So let us take a look at what's inside in the provider. So basically we just copied the Terraform block in the Azure RM provider block. Next will be the variables TF. We will have in the future lecture or tutorial on variables in Terraform, but similarly in your programming, so it store values. So for example, we have a variable here, a single variable named prefix. So the default is this string vm-example. So we will use this variable prefix to be, maybe as you guess, to be the name of our VM. Then next will be the main TF. So we'll take a look at the main TF code. So here it enumerates all the blocks that will satisfy the diagram wherein we need to create the resource group. Next will be the virtual network. Next will be the Azure subnet. Next will be the network interface card. And finally, you have the Azure virtual machine. And there is an OS disk in this virtual machine, so it's not a separate resource block for creating that OS disk. So we have it here under the resource Azure RM Windows virtual machine. Let's take a look closely at each of the resource blocks. So you have the Azure RM resource group. The name for this resource is RG. And the name of the actual resource group that we will be creating is rg-terraform-part 3. You will notice also that it is a string, and you will say perhaps you could use variables for that. Again, I'm just making this video a bit simpler. So we only have one variable that will be used on the virtual machine itself. But you are right, you can replace this with a variable as well. Next will be the creation of the Azure Virtual Network. So resource Azure RM Virtual Network. The name of this resource is VNet. You can name it whatever you want. For example, I could name it also as example here. But again, for simplicity, I just term it as VNet. The name of the actual virtual network that will be deployed in Azure is this VNet-example. The address space, so you remember it, the virtual network will be assigned with a CIDR block. So we have 10.0.00/16. Okay, so this VNet, if you notice, will be placed under the resource group name. So the resource group name is whatever name this RG is referenced to. In this scenario, it is the rg-terraform-part number 3, and the location will be Southeast Asia. Next is our subnet. So we can name it like SNet for the VM, but again, for this tutorial, let's just make it simple. So it's using the resource name Azure RM-subnet, and this is the name of that one. So SNet-example, and it will be deployed similarly on the same resource group name. It will be tied to this virtual network name, which is a requirement for subnet. Then of course, a subnet should have an address prefix. Again, we are taking from the virtual network. So we have 10.0.2.0/24. Next is the creation of the VM's network interface card. So using this resource name, Azure RM-network-interface. The name of this will be NIC. So now we are using the variable, okay? So var.prefix -nic. And if you remember, our variable is vm-example. So it will become vm-example-nic. Similarly, like the preceding resources, it will be deployed under the resource group name rg-terraform-part3 and with the same location. But the network interface will have its IP configuration. Okay, so this is a requirement wherein you declare whether it's dynamic or static. So for simplicity, so we have selected dynamic. The subnet ID is the SNet subnet ID. So meaning to say this network interface card is being tied to a subnet because you could have many subnet. So you have assigned it to this SNet. So if we have another resource, Azure RM subnet, which is maybe perhaps SNet2, and we want to tie this network interface card to that new subnet, then we will need to change this. But since we have only one subnet, so that's why this is the assignment. Then finally, the creation of our Azure virtual machine. So using this resource, Azure RM Windows virtual machine resource type. The reference name for this resource is the VM or VM. So the name of our VM is whatever the content of this variable, var.prefix, so variables. So it will be VM-example. It will be deployed in this resource group like we have the rg-terraform-part3. The location will be Southeast Asia. The size of the virtual machine is standard underscore bf4ms. So we have different VM sizes, so we can check that out. So what are the Azure VM sizes? The admin username, again for simplicity, we'll make use of this. This VM will make use of the NIC reference name or resource name that we have configured in the preceding block, which is the network interface. So next you have the OS disk. So OS underscore disk. So caching, read write, the size in GB, so 1024 or it is 1 terabyte. So the storage account type is standard underscore LRS. Okay, so the disk, so standard LRS, or it stands locally redundant storage. So depends on what are your redundancy needs in your OS disk. So we have GRS, ZRS, and not also only standard, but you have premium as well. So now that we have disk, we have the NIC. So you again, the B4MS, you'll have your CPU and your memory. So B4MS is 4 vCPU and 16 gig. So you have your CPU, you have your memory, you have your NIC, and you have your disk, and what's left is really what is the image that you'll use. So we'll deploy a Windows server. So we have Linux and Windows as well flavors in Azure. So in this example, we'll deploy from a source image provided by Microsoft, which is this one, the publisher. So Windows Server 2022 Data Center, the latest version. Then what's left is the output TF. So output TF mainly is used for verification purposes. So to output what resources that we have deployed or created so far. So normally whatever you have deployed in the main TF, you would like to have it verified using your output TF. So for example, we deployed a resource group. We know what we want, the location, the VNet name and the address space of the VNet. We want to confirm the subnet name and the subnet address. Okay, the next is the nickname. You have the IP config, so see the IP configuration of that NIC, then the VM name. Okay, so we don't know if we have any typo issues with our code in main and variables and even providers. So nevertheless, let's do the Terraform commands. So if you can remember, it starts with Terraform init. So to prepare our working directory, so it should have these providers, but it will return to some errors if we have some errors here. So let's enter the Terraform init. Okay, so it's initializing. So it's creating that Terraform. and these providers and the Azure RM providers, and installing it. Okay, so we have successfully initialized our Terraform. Next is to validate. So obviously the word validate checks whether the configuration is valid. So I'll just do a CLS to make it clear. So Terraform validate. So enter, and let's perhaps shift this. Okay, so success, the configuration is valid. So next will be Terraform plan. Terraform plan. Okay, so Terraform plan shows the changes required by the current configuration. So our current configuration is this one, and hit enter. Okay, so we have the log file and the state files. All right, so we have the Terraform plan, and let's read them from the top. So perhaps we maximize a bit. So it says Terraform will perform the following actions. It will create a network interface, and these are the settings for that, the IP configuration. Okay, so it's dynamic as what we wanted. IPv4, our resource group will be created. This is the name. A subnet with this prefix will be created. Okay, and it will be under the VNet. Okay, so a VNet will be created. Okay, some of the settings will be known after application. So the location and the name and the resource group. Then finally, our virtual machine. Okay, so we have these settings and the OS disk and the source reference image. So we have 5 to add, nothing to change, and nothing to destroy. Okay, so before we do a Terraform apply, so let's go back to our Azure portal. Again, we don't have yet Terraform part 3 in our resource groups. So the expectation is if the Terraform apply is successful, we should have a new rg-terraform part 3, and it should have the resources such as virtual network. Inside of it will be a subnet. We have the network interface card, and we have the VM, and we have the OS disk for that VM, and of course that NIC is attached to that VM. Okay, so we go back to our Visual Studio Code. So again, going back, this should be created. A new resource group -part 3, the virtual network, the SNet, and the virtual machine, and the NIC, and the OS disk. Okay, so again, to do a CLS, okay, to clear, and let's do a Terraform apply. Okay, so says here, so these are the changes. And we know this already with the Terraform plan. So it says only yes will be accepted. So enter a value. So we type yes here. So enter a value yes. So to confirm that we want to perform these actions. Okay, so Azure resource group creating. So creation complete after 3 seconds. Then it's doing the VNet, then the subnet, then creating the NIC, and it's done with the NIC, and now it's the VM. Obviously it will take some time versus creating the RG and the other resources, because virtual machine, so you need to prepare the computer itself. Okay, so you have the correct standard, the OS disk, and using that image. So it will take some time, and let's just wait. Okay, so Terraform apply was completed. So if I scroll up, so the VM creation, so 1 minute and 30 seconds. So after 1 minute and 33 seconds. So apply complete. So resources 5 were added, nothing changed, nothing destroyed, and these are the result of the output. Okay, so we have the RG name, the RG location, the SNet, the VNet. Okay, so the VNet name. So these are the result of the output. So we have our private address 10.0.2.4. So even though we are not yet looking at the Azure portal, so we will know that the VM's private IP address is 10.0.2.4. So it's time to verify it in the Azure portal itself. Okay, so let's hit refresh. And yes, you have it, the RG Terraform hyphen part 3. So we created our resource group. Then under this resource group, you have the VNet or the virtual network. So we click on this one. And this VNet, so under settings, the address space is 10.0.0.0/16. That's what we wanted. Next is we created one subnet, SNet hyphen example under the 10.0.2.0/24 network. Next, we go back to the resource group and we go to our NIC or network interface card. So settings, IP configurations, and we know already that is 10.0.2.4, okay, from the Terraform output. But again, to verify here in the actual Azure.portal, we go back again to our resource group. Let's take a look at the virtual machine OS disk, and you have it as 1 terabyte as what we wanted, and it's managed by the VM, the standard HDD LRS. That's what we wanted for our example. So that is the OS disk. Then finally, you have your virtual machine. So the name is VM-example, and you have your standard B4 MS here. So 4 vCPUs and 16 gig. We want our image to be Windows Server 2022 data center. So that's what we wanted. So obviously, if you go to settings, you'll take a look at the disk here. Okay, that VM example disk 1 terabyte is attached to this one, and the networking settings for this VM is being assigned to that NIC. So currently, yeah, VM example hyphen NIC, and if you go here, you still go to that IP configuration, and the IP address is 10.0.24. So yes, we indeed successfully configured per our diagram. So the resource group hyphen part 3, the virtual network, the subnet, the NIC, the OS disk, and the virtual machine. Okay, so as not to incur any fees or payments, more payments for our deployment or our test deployment, so it's time to do the other Terraform command, which is to destroy. So CLS, enter. So Terraform destroy. Okay, so again, you do this command very carefully, especially on production environment. This is only for our tutorial, and this is for laboratory. We can afford to destroy these resources because again, these are for testing. So again, beware for this command. Okay, so the Terraform destroy has initialized and what other things that will be destroyed. Okay, so if we go up, okay, so refreshing state. So these are the things. Terraform used selected providers, destroy. It will perform the following actions. The NIC will be destroyed. So these configurations, the resource group will be destroyed, the subnet will be destroyed, the VNet will be destroyed, and you have the virtual machine will be destroyed. And if you are really okay with this, okay, So you have nothing to add, nothing to change, 5 to destroy. If you can remember, we have 5 resources that we added. So you have 5 to destroy. So if you are sure, so only yes will be accepted to confirm. So we are sure because this is only a sample example laboratory tutorial environment, so we can afford to type yes and destroy the infrastructure. Okay, so Terraform destroy is done. So when we selected or we type yes to confirm, so it goes to this process, so it destroys the resources that we wanted. Okay, so still destroying the NIC and destroying the SNet. Then you have the VNet, destroying the VNet and destroying the RG. And yes, destroy complete resources, 5 destroyed. So there's only one verification left, which is to go to the portal itself and we go to the resource groups and we refresh. And yes, our rg-terraform-part3 is now gone.